Imagine, if you will, a baby born so small he could fit inside a quart mug. That was Isaac Newton, who arrived on Christmas Day in 1642, a tiny and frail infant nobody expected to survive. His father, also named Isaac, had died 3 months before he was born, leaving his mother to manage their farm in the small English village of Woolsthorpe by Colsterworth. Life started out, pretty uncertainly for the boy who would one day explain the universe. When Isaac was just 3 years old, his mother remarried and moved to a nearby village, leaving him in the care of his grandmother. This early separation was difficult, and young Isaac grew into a quiet and thoughtful boy, often lost in his own world of ideas and inventions, a world far removed from the dirt and demands of the family farm. While other boys his age were learning to plough fields and tend to livestock, Isaac was busy with far more intricate pursuits. He wasn't interested in farming, his mind was captivated by how things worked. He filled his notebooks with drawings of machines and spent his free time building remarkable models. He crafted a small windmill that could actually grind flour, powered by a mouse he had trained to run on a tiny treadwheel. He made water clocks that dripped with surprising accuracy, and kites with lanterns tied to their tails, which he flew at night to frighten the local villagers into thinking they were comets. These weren't just toys, they were early experiments, the first stirrings of a scientific genius trying to understand the principles of mechanics and motion. Fortunately, an uncle recognized that Isaac's talents were being wasted on the farm. He saw the boy's potential and persuaded his mother to send him back to school to prepare for university. This was a pivotal moment. Isaac was enrolled at the King's School in Grantham, where he could finally dedicate himself to his studies. He excelled not just in his lessons, but also in his continued tinkering. He was fascinated by the sun and created sundials all over the place, using shadows to tell time with impressive precision. His schoolmasters saw a brilliant, if somewhat solitary, student. Thanks to their encouragement and his uncle's foresight, Isaac was accepted into Trinity College, Cambridge in 1661, ready to step into a much larger world of knowledge. At Cambridge, Isaac plunged into the works of the great thinkers of his time. He studied mathematics, philosophy, and the sciences as they were then known. He read the works of Aristotle, the ancient Greek philosopher whose ideas had dominated Western thought for centuries. But Isaac was more interested in the newer, more radical thinkers like René Descartes and Johannes Kepler, who were challenging old assumptions about the natural world. He filled a notebook with his own questions and ideas, titling it "or certain philosophical questions." He wasn't just absorbing information, he was questioning everything, laying the groundwork for the revolutionary ideas that would soon pour from his incredible mind. In 1665, a terrible event changed everything. The Great Plague, a devastating epidemic, swept across England, forcing cities and institutions to shut down. Cambridge University closed its doors, and Isaac Newton, now a young graduate, had to return to his family farm in Woolsthorpe. For many, this was a time of fear and isolation, but for Newton, it was an opportunity. Away from the structured life of the university, his mind was free to wander, explore, and create. This period of intense intellectual activity, lasting about 18 months, is now famously known as his, or Year of Wonders. It was here, in the quiet solitude of the countryside, that the foundations of modern science were laid by one man and his boundless curiosity. It was during this time that Newton invented a whole new branch of mathematics, calculus. He called it his method of fluxions. He needed a tool to describe how things change, like the speed of a falling object or the curve of a planet's orbit. Existing mathematics wasn't up to the task, so he simply created what he needed. At the same time, he became fascinated with light. He bought a glass prism at a local fair and began a series of brilliant experiments in his darkened room. By drilling a small hole in a window shutter, he allowed a single beam of sunlight to pass through the prism. The result was a stunning spectrum of colors, just like a rainbow projected onto the opposite wall. This simple observation led to a groundbreaking discovery. The common belief at the time was that the prism somehow colored the pure white light. But Newton suspected something different. He cleverly used a second prism to show that the separated colors could be recombined to create white light again. This proved that white light was not pure, but was in fact a mixture of all the colors of the rainbow. He had fundamentally changed our understanding of light and color, a discovery that would later form the basis of his book. This work alone would have secured his place in history, but his mind was already grappling with an even bigger puzzle: The most famous story from this period is, of course, about an apple. While the tale of an apple falling directly on his head is likely an exaggeration, Newton himself confirmed that a falling apple in his garden made him wonder about the force that pulled it down. If this force, which he called gravity, could pull an apple from a tree, could it be the very same force that reached all the way to the moon, keeping it in orbit around the Earth? This was a revolutionary leap of imagination. The idea that a single universal law governed both the falling of an apple and the motion of the heavens was the seed that would eventually grow into his universal law of gravitation. When Newton returned to Cambridge after the plague subsided, he brought his incredible discoveries with him. His work on light and his new mathematical tools quickly earned him recognition. In 1669, at the remarkably young age of 26, he was appointed the Lucasian Professor of Mathematics, a prestigious position he would hold for over 30 years. One of his first major projects was to build a new kind of telescope. Telescopes at the time used lenses which suffered from a problem called chromatic aberration. They produced images with blurry, rainbow-colored edges. Drawing on his discoveries about light, Newton designed a reflecting telescope that used mirrors instead of lenses, which produced a much sharper and clearer image. It was a triumph of practical science. For years, Newton kept many of his most profound ideas, especially those about gravity and motion, largely to himself. He was a private and often secretive person, hesitant to publish his work for fear of criticism. It was only through the persistent encouragement of his friend, the astronomer Edmund Halley, that he finally agreed to compile his ideas into a single monumental book. Halley even paid for the printing costs himself. The result was published in 1687. Often called simply it is widely considered the most important scientific book ever written, a work that would define physics for the next 200 years. Within the pages of Newton laid out his three famous laws of motion. The first law states that an object will stay at rest or continue moving in a straight line unless a force acts on it. The second explains how force, mass, and acceleration are related. F equals ma. The third law is the famous principle of action and reaction. For every action, there is an equal and opposite reaction. These three simple-sounding laws provided a complete framework for understanding how objects move, from a thrown ball to a spinning planet. They were universal, applying everywhere and to everything, and they gave scientists the tools to predict the behavior of the physical world with astonishing accuracy. The crowning achievement of them was Newton's law of universal gravitation. Building on that idea sparked by the falling apple, he described gravity as a force of attraction between any two objects in the universe. He showed that this force depends on the mass of the objects and the distance between them. Using this single, elegant law, he could explain why an apple falls to the ground, why the moon orbits the Earth, and why the planets move around the sun in the paths that Kepler had described. He had united the heavens and the earth under one set of physical laws, revealing a universe that was not mysterious and chaotic, but orderly, predictable, and understandable. Even after publishing Newton's work was far from over. In 1704, he published a book that summarized his decades of research on light and color. Written in English rather than Latin, it was much more accessible to a wider audience and solidified his reputation as a master of experimental science. But as he grew older, his focus began to shift from pure scientific inquiry to public service. In 1696, he left the quiet world of Cambridge for the bustling city of London to take on a new role as Warden of the Royal Mint, the institution responsible for making England's coins. He took the job very seriously, applying his scientific mind to a very practical problem. At the time, England's currency was in a state of chaos. People would clip small shavings of silver from the edges of coins, devaluing the money. Counterfeiting was also rampant, threatening the nation's economy. Newton threw himself into the task of reforming the system with incredible energy. He used his knowledge of chemistry and metallurgy to improve the quality and consistency of the coins, and he personally oversaw a massive effort to recall old currency and issue new, more secure coins with milled edges to prevent clipping. He also acted as a detective, going undercover in taverns and chasing down leads to catch and prosecute some of London's most notorious counterfeiters, bringing a scientific rigor to law enforcement. Newton's influence extended far beyond the Mint. In 1703, he was elected President of the Royal Society, the most prestigious scientific organization in England. He ruled over it with an iron fist for 24 years until his death, using his immense authority to shape the direction of British science. In 1705, his lifetime of achievement was formally recognized when Queen Anne travelled to Cambridge to knight him. He was now Sir Isaac Newton, a national hero celebrated not for winning a battle, but for unlocking the secrets of the universe. It was a powerful symbol of how science was gaining a new and profound importance in the world. Sir Isaac Newton died in 1727 at the age of 84 and was given a state funeral, an honour usually reserved for kings and queens. He was buried in Westminster Abbey, a testament to the extraordinary impact he had on his country and the world. His discoveries completely transformed science, turning it from a collection of observations into a powerful predictive system built on mathematical laws. He gave humanity a new sense of its place in a grand mechanical universe. Yet despite his immense achievements, Newton remained humble. He famously reflected on his life's work by saying, "If I have seen further, it is by standing on the shoulders of giants."